Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So we are going to solve the given differential equation using three ways of variation of parameters method in three different parts. So let's begin with part 1. Problem. Solve y double dash plus y equal to secant x cosecant x or d square plus 1 into y equal to secant x cosecant x using variation of parameters method. So here we are given a differential equation of order 2, right? Given differential equation y double dash plus y equal to secant x cosecant x considered as equation 1. We can write y double dash as d square y by dx square plus y equal to secant x cosecant x, and we can write d square y by dx square as capital D square y, right, using differential operator d. Now take y common from the two terms of LHS, will get d square plus 1 into y equal to secant x cosecant x considered as equation 2, which is in operator form. So equation 1 in operator form is equation 2, right? Say sum f of d into y equal to some function of x, where f of d is d square plus 1. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus 1 into y equal to 0, considered as equation number 3. Now we'll find the solution to equation 3 using the auxiliary equation, and later the solution of homogeneous equation will find the general solution of 1 and 2. Here 1 and 2 are same equations, got it? So now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d equal to d square plus 1, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square plus 1, and the auxiliary equation becomes m square plus 1 equal to 0. We need to find roots to this equation. M equal to plus or minus square root of minus 1, since square root of minus 1 is I, so we'll get plus or minus I. Therefore m equal to plus or minus I. The roots are complex conjugate. We know that when two roots, say m1 and m2, or here we got complex conjugate roots, right? When a equal to a plus or minus ib, the solution to homogeneous equation looks like y equal to some e power ax into one constant into cos bx plus another constant into sin bx, right? In case of a0, we'll get e power 0 into x, which is e power 0. E power 0 into c3 cos bx plus c4 sin bx, since e power 0 equals to 1, right? So this gives us 1 into c3 cos bx plus c4 sin bx, right? It gives us c3 cos bx plus c4 sin bx, right? Let's now write the solution to our homogeneous equation. Here we are taking c3 and c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution. The solution to the homogeneous equation equation number 3 is y equal to C3 cos, just compare plus or minus I with plus or minus IB. Then for B equal to 1, we'll get 1x plus C4 sin 1x, right? Which gives us C3 cos x plus C4 sin x. Therefore, y equal to C3 cos x plus C4 sin x is the solution to our homogeneous equation. Okay. Let y equal to, now replace the constants or parameters with functions of x, a and b. We'll get a cos x plus b sin x, where a and b are functions of x, right? Let y equal to a cos x plus b sin x be the general solution to 1 and 2. Okay, we are saying that y equal to a cos x plus b sin x is the general solution to equation 1 and 2. So it is a solution to 1 and 2, right? So we can say that it satisfies equation 1. Okay, now let's find y double dash and substitute y double dash in equation 1. Okay, we have y equal to a cos x plus b sin x. Let's now find y double dash. In order to find y double dash, we need to find y dash also. So now we are going to find y dash. Y dash equals to a cos x whole dash plus b sin x whole dash. Here we are having two functions, right? So we are going to apply uv whole dash formula. U dash v plus v dash u. This gives us a dash cos x plus a into cos x dash plus b dash sin x plus b into sin x whole dash, which gives us a dash cos x plus a into derivative of cos x with respect to x is minus sin x plus b dash sin x plus b into derivative of sin x with respect to x is cos x. This gives us a dash cos x plus into minus minus a sin x plus b dash sin x plus b cos x. Now let's remove the brackets. Now write the terms involving a dash and b dash. A dash cos x plus b dash sin x. Now write the terms involving a and b. Minus a sin x plus b cos x. Let a dash cos x plus b dash sin x equals to 0. Consider as equation number 4. Then y dash becomes 0 minus a sin x plus b cos x, or y dash equals to minus a sin x plus b cos x. So we got y dash. See, we are taking it as 0 because while finding y double dash, a double dash and b double dash will not appear. Okay. Here we have taken a dash cos x plus b dash sin x equals to 0. We have considered as 4. Later we'll use this equation to find a dash and b dash. Okay. Since we are considering it as 0, so that while finding y double dash, a double dash and b double dash will not appear. Fine. Now we got y dash. Let's now find y double dash. We have y dash equals to minus a sin x plus b cos x, right? Let's now find y double dash. Y double dash equals to minus of a sin x whole dash plus b cos x whole dash, right? This gives us minus of, here we are having two functions, right? We need to find derivative of two functions, that is product of two functions. So we'll apply uv whole dash formula, u dash v plus v dash u. This gives us a dash sin x plus a into sin x whole dash plus b dash cos x plus b into cos x whole dash, right? This gives us a dash sin x plus a into derivative of sin x with respect to x is cos x plus b dash cos x plus b into derivative of cos x with respect to x is minus sin x, which gives us minus of a dash sin x plus a cos x plus b dash cos x plus into minus minus b sin x. This gives us minus a dash sin x minus into plus minus a cos x plus b dash cos x minus b sin x, right? Now let's write the terms involving a dash and b dash. Firstly, we'll get minus a dash sin x plus b dash cos x minus a cos x minus b sin x, right? So we got y double dash minus a dash sin x plus b dash cos x minus a cos x minus b sin x. We have equation 1, y double dash plus y equal to secant x cosecant x. Now substitute y double dash, then we get y double dash minus a dash sin x plus b dash cos x minus a cos x minus b sin x plus y a cos x plus b sin x equal to secant x cosecant x. This gives us minus a dash sin x plus b dash cos x minus a cos x minus b sin x plus a cos x plus b sin x equal to secant x cosecant x. So here minus a cos x plus a cos x gets cancelled. Likewise, minus b sin x plus b sin x gets cancelled, and this results to minus a dash sin x plus b dash cos x equal to secant x cosecant x, considered as equation number 5, right? Now by solving equation 5 and equation 4, we'll get a dash and b dash. Let's now solve 4 and 5. Now just observe the terms containing a dash. In first term we are having a dash, right? A dash cos x, and here we are having minus a dash sin x. In order to solve these two equations, if we want to cancel the term involving a dash, firstly we need some sin x here, and a cos x here, right? So what we'll do is, we'll just multiply equation 4 with some sin x and equation 5 with a cos x, right? And let's solve 4 and 5. A dash sin x cos x plus b dash sin x into sin x is sin square x equal to 0. Multiply equation 5 with cos x, we'll get minus a dash sin x cos x plus b dash cos x into cos x is cos square x equal to secant x cosecant x cos x, right? This gives us here plus a dash sin x cos x and minus a dash sin x cos x gets cancelled, and we'll get b dash sin square x plus b dash cos square x equal to secant x cosecant x cos x, which gives us, just take b dash common from the two terms of LHS, we'll get b dash times sin square x plus cos square x equal to, we can write secant x as reciprocal of cos x, right? So that we can cancel cos x, and we know that sin square theta plus cos square theta equal to 1. So this becomes 1 equal to cosecant x, right? This gives us b dash equals to cosecant x. Therefore, b dash equals to cosecant x. We have equation 4, right? Just substitute b dash in equation 4 so that you'll get a dash. Now coming to equation 4. We have equation 4, a dash cos x plus b dash sin x equals to 0. We can write it as a dash cos x equals to minus b dash sin x, right? Or just substitute b dash now. Since b dash equals to cosecant x, this gives us minus cosecant x into sin x, right? We can write cosecant x as reciprocal of sin x. Now cancel sin x, we'll get minus 1, right? That is a dash cos x equals to minus sin x. Or we can write it as a dash equals to minus 1 by cos x, which gives us minus secant x, since reciprocal of cos x is secant x. Therefore, a dash equals to minus secant x. Right? Now we got a dash and b dash. Let's find a, b. We have a dash equals to minus secant x, right? A dash is nothing but derivative of a with respect to x. Let's now separate the variables by taking differential dx to RHS. We'll get dA equal to minus secant x dx, right? Here the variables are separable. So we can perform integration. This gives us, since we know that integral secant theta d theta equal to log mod secant theta plus tan theta, right? And integral d theta equals to theta, we'll get a equal to minus log mod secant x plus tan x plus some integral constant says c1. Therefore, a equal to minus log mod secant x plus tan x plus c1. We got a. Let's now find b. We have b dash equals to cosecant x, right? And b dash is nothing but derivative of b with respect to x. Let's now separate the variables by taking differential dx to RHS. Then we'll get dv equal to cosecant x dx. Here the variables are separable. So let's perform integration. Integral dv equal to integral cosecant x dx. Since we know that integral cosecant theta d theta equal to log mod cosecant theta minus cot theta, and integral d theta equal to theta, then integral dv equals to b equal to integral cosecant x dx is log mod cosecant x minus cot x plus some integral constant, say c2. Therefore b equal to log mod cosecant x minus cot x plus c2. We got b. Log mod cosecant x minus cot x plus c2. So we got a and b. Let's now write the general solution using y equal to a cos x plus b sin x. Therefore, the general solution is given by y equal to a cos x plus b sin x. This gives us a minus log mod secant x plus tan x plus c1 into cos x plus b log mod cosecant x minus cot x plus c2 into sin x. This gives us y equal to minus cos x log mod secant x plus tan x plus c1 cos x plus sin x log mod cosecant x minus cot x plus c2 sin x, or write the terms involving c1 and c2. Firstly, we'll get y equal to c1 cos x plus c2 sin x minus cos x into log mod secant x plus tan x plus sin x into log mod cosecant x minus cot x, which is the required general solution to a given equation. Or we can write it as y equal to c1 cos x plus c2 sin x minus cos x log of secant x plus tan x plus sin x log of cosecant x minus cot x. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.